All right, this is the review for test unit 4, similarity. So hopefully you have your packet out so that you can follow along and figure out anything that you have problems with. For number 1, I want to complete the similarity statement for the two similar triangles given. Well, I know I'm using WBA, and I'm using, so the other one would be WYX. Since they're overlapping, I'm going to draw mine out separately. I know that angle A is 60 degrees. Because I know that this angle and this angle make my line, I know they're add up to 180, so I know the angle WXY is 60 degrees. So I have at least one pair of congruent angles. And then if I look at my triangles, when I drew them out, I drew angle W. I drew because XWY is the same one angle as AWB. So here's my other congruent angle. So triangle WBA is congruent to triangle WYX by angle. So there's number 1. Number 2, I want to determine if the two triangles are similar. And if they are, I want to state my reason, either side, side angle, side similarity, or angle similarity. Well, automatically in letter A, I know I have a pair of angles. So I can automatically get rid of side, because I have a pair of angles. I only have one angle, but I have two sets of sides, so let's see if they are proportional. I have 8 and 18 in one triangle. Well, the small side of my little triangle is 4, so that goes with the 8. And the big side of my little triangle is 9, so that goes with the 18. And 8 over 4 simplifies to 2 over 1. 18 over 9 also simplifies to 2 over 1. So our sides are proportional. So A is similar by side, angle, side similarity, because we have the side, the 8 and the 4, then we have the angle, then we have the 18 and the 9. So side, angle, side. In B, I don't know any information about any of my angles, so the only possible one would be side, side, but before I can just write down side, I have to check my proportions. The small side of my bigger triangle is 24. The small side of my little triangle is 15, so 24 over 15. The medium size of my big triangle is 32. The medium side of my little triangle is 20. My big side of my big triangle is 40. The big side of my little triangle is 25. So then I have to check to see if all of these simplify to the same thing. 24 over 15 simplifies to 8 over 5. Check these in the calculator if you need to. 32 over 20 simplifies to 8 over 5. 40 over 25 simplifies to 8 over 5. So these are similar by side similarity. Letter C, I don't have any information about sides, but I do know that these angles are congruent and these top angles are congruent. So these two are similar by angle similarity. In D, all I know is that I have these two parallel lines. Well, I have a transversal here. Whoops, words off. I have a transversal here. So I know that this angle and this angle are congruent. And then I have a transversal here, so I know these two angles are congruent. So these two triangles are congruent by angle. In E, so far I know I have my two right angles. To figure out if I have another pair of congruent angles, I need to figure out angle M and angle T. Well, angle M would be 30 degrees, in which case I know angle M is congruent to angle Q. So E is also similar by angle similarity. In F, I have a pair of congruent angles, but I only have one, so it could be side angle side, but I have to check my proportions first. The little side of my big triangle is 18. The little side of my little triangle is 12, which simplifies to 3/2. The big side of my big triangle is 24. The big side of my little triangle is 16. And again, I get 3/2. So these are proportional. So these two triangles are similar by side angle side similarity. G. I have some congruent pieces here. I know that my small piece of my big triangle is 8. The small piece of my little triangle is 6. And so 8/6 simplifies to 4/3. The big piece of my big triangle is 12. The big piece of my little triangle is 9. And that again simplifies to 4/3. And then I have 12/9 again because I have the congruent pieces. So I have that all my ratios simplify to 4/3. So this is side, side, side similarity. So looking at number 2, just because all of ours on the review working did end up being similar, doesn't mean the ones on your test will always end up being similar. So make sure you are careful that you are looking for only side, 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 and angle, angle. Number 3, find the scale factor and the missing variables. So I'm looking at my two triangles. Here's my one triangle, which I'm going to draw out separately. So I have 6, 8, and x. And I have my bigger triangle. Again, I'm going to draw it separately. The bottom piece is 26. This side here is y plus 6. And this side here would be 8 plus 12, which is 20. So I'm going to set up all my ratios. The 6 on my little triangle. The 6 on my little triangle goes with the y plus 6. The 8 on my little triangle, whoops, wrong color. The 8 on my little triangle goes with the 20. And then the x goes with 26. So for my scale factor, I want to look at this piece that just has numbers. And I want to say, okay, what's my scale factor? What does 8/20 simplify to? Well, that is 2/5. So I'm going to use the 2/5 to find x and y. Because I know all of my ratios will simplify to 2/5 since they're all proportional. So for x, I want to use my 2/5, and I want to use the x/26. Cross multiply. I get 52 equals 5x. Divide by 5. And I get that x is 10.4. For y, I need to use the 6/y plus 6. And I'm going to go back to using that 2/5. I cross multiply. I get 30 equals 2 times y plus 6. I'm going to divide by the 2. So I get 15 equals y plus 6. Subtract the 6. So I get y equals 9. So there's my answers. For number 4, I know that ABC is similar to EFD. So AB is x, so I have x over EF is 18. So x/18. BC is 12. Well, BC goes with FD. FD is 24. Then AC is 8. DE is y. So 8 and y go together. So then my scale factors, I want to simplify 12/24. So my scale factor simplifies to 1/2. And I'm going to use that 1/2 figure out x. Because I know x over 18 will simplify to 1/2. So I cross multiply. I get 18 equals 2x, divide by 2. I get x equals 9. For y, I'm going to use the 8 over y and the 1/2. So 1/2 equals 8 over y. Cross multiply. I get y equals 16. So there's number 4. Number 5, use the diagram at the right and solve for x and y. Well, first of all, I want to figure out all my angles in here. Angle A is going to be 30 degrees, or I mean 60 degrees, sorry, because 90 plus 30 is 120. 120 subtracts from the 180 is 60. Well, now I want to look at which angles are congruent. I know that angle A is congruent to angle F. So y is going to be 60 degrees. All right, so y equals 60 degrees. So for x, all right, for x, I know that's ED. So ED is going to go with BC, which is 8. So 8 over x is going to equal, well, let's see. I know AB goes with FD. So that's going to equal 6 over 3. And then AC goes with FE, which is 5. So then we have, so I can pick either one of those to solve this. I'm going to pick the purple one because it's right next to it. Cross multiply. 6x equals 24. So I get that x equals 4. Using the diagram below, solve for x. Okay, so I'm going to use my little pieces. Because I know this whole entire side is 10, this piece is 6, and this piece is 4. So I have two options from here. I can use my proportional parts. It tells me that 6 over 4 is equal to x plus 2 over 5. And cross multiply, so I'd get 30 equals 4 times x plus 2, divide by 4. So this would be 30 over 4 is 7.5 equals x plus 2, subtract the 2. There's one method. I also can look at my two separate triangles. So I have this piece here, 6x plus 2. And I can look at this piece right here, 10. And this is x plus 2 plus 5, which is equal to x plus 7. So then I would know that 6 over 10 equals x plus 2 over x plus 7. Cross multiply. 6 times x plus 7 equals 10 times x plus 2. Distribute 6x plus 42 equals 10x plus 20. Subtract the 6x. Subtract the 20. 22 equals 4x. Divide by 4. And again, I get x equals 5.5. So either way you want to do this problem, you still get 5.5. Next problem. The perimeter. The perimeter has the same ratio as our sides. So I want to set up some proportions. I know that AB goes with DE. So 18 over 7.2. And I want to what is the proportion? I want to figure out the perimeter of the big triangle. So 18 plus 12 plus 9. So this perimeter is 39. So I can set this equal to 39 over x. Cross multiply. And I get 280.8. Divide that by 18. My perimeter is 15.6. All right, so this one, if the two triangles are similar, give the reason and fill in the triangle names that are similar. So this time, I'll look at my side proportions. My small side is 4 on the big triangle. On the little triangle, my small side is 2. With my medium side is 16. My medium side is 8. My large side is 18. My large side here is 9. Let's see what we simplify to. 4 over 2 is 2. 6 over 8 is 2. 18 over 9 is 2. So these are similar because they have the same ratio. So similar by side, side, side. So then RST, so I go from the little side to the big side. So little side to big side needs to be MPQ. Next one. I know that angle B is congruent to angle D, and I have some verticals here. These two are similar by angle similarity, and ABC is similar to EDC. Next page. All right, to figure out my last angle, 115 plus 35 is 150. Subtract that from 180, I get my last angle L is 30. So I have the two 30-degree angles. I have the two 35-degree angles. So these two triangles are congruent by angle similarity. And JKL is congruent to FGH. Next problem. All right, this one I want to look at the angles in the big picture. My 70-degree angle is in between the 4 and the 6. In JKL, my 70 is not in between the 2 and the 3. So these are not similar because I don't have side angle side here. E. My little side is 6. Over here, my little side is 9. And 6 and 9 is, of course, going to be equal to 6 over 9. And then 7.2 over 10.8. Well, 6 over 9, if I check it in my calculator, simplifies to 2/3. So really the important one I need to check is the 7.2 divided by 10.8 simplify to 2/3, which it does. So these two triangles are similar by side, side, side similarity. And MNP goes to QRS. Next page. All right, I want to use the word bank to list two pairs of similar triangles. Some items will not be used. All right, well, first of all, I have some parallel lines. So I know that my entire triangle, my big triangle, which is ACB, is similar to AED. Then I also know, using some verticals, this angle is congruent and this one here is congruent to this one here. So the other one I know is I know that BFC is similar to DFE. Number 10, find the length of AC. So I set up my right triangle. I went down 8. This one's the square root of 80. CE, I go down 2 over 1, 2, 3, 4, 5, 6, 7, 8, which is the square root of 68. BC went down 4 over 2, which is the square root of 20. And then CD, I went down 1 over 4. The square root of 17. I'm going to put these on my calculator. If I simplify these, this simplifies to 4 root 5. This one simplifies to 2 root 5. 2 root 17. So these are all going to have a ratio of 2 to 1. Because 4, or square root of 80 over the square root of 20 is 2 over 1. And the square root of 68 over the square root of 17 is also 2 over 1. So these are, yes, similar. Oh, wait, we need the angle. Is ACD the same angle as BCE? Yes. So they are similar by side angle side. Next page. All right, the midpoint of AC. So just a straight line. Distance from AC is 1, 2, 3, 4. I went down 12 and didn't go over at all, so divide that by 2. I have to go down 6. That ended me up right here at point B, which is negative 5, 0. For AE, I went over 12, up 6, divide that in half. I want to go up 3 and over 6. So over 6, up 3. Here at point D, which is the point 1, negative 3. So, and then I'm looking at, is DAB the same as EAC? Yes. Are the two triangles similar? Well, yes. But as we look here, ABD, well, B and D are the midpoints, so this is half of the length. So my ratio is 1/2. So these are similar by side angle side similarity. Next one. AB, I had to go down 4 over 1. 4 squared plus 1 squared is the square root of 17. AC, over 5 down 1. 5 squared plus 1 squared, square root of 26. BC, over 4 up 3 is 25, so that's just 5. ED, I had to go down 8 over 2. So that's the square root of 68. DF, I want to do EF first, sorry. EF over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, down 2, which is the square root of 104. And lastly, DF, I went over 8 up 6, which is 10. So when I make my ratios, the square root of 17 over the square root of 68 gives me 1/2. 5 over 10 equals 1/2. The square root of 26 over the square root of 104 gives me 1/2. So all of my proportions are the same, so these triangles are similar by side, side, side similarity. Next page. Number 13. So a word problem. Looking at this picture, I know that the x, height of the tree, goes with the height of the person. The length of the shadow goes with the length of the shadow. So this is the height and shadow. So figure out x. Cross multiply. Divide by 5. So I get 50 0.4 equals x. This is 50.4 feet. Do not forget your units. All right, so tree casts a 13-foot shadow. While a 5-foot tall person casts a shadow that is 1.5 feet long. And here's my tree. I want to figure out what is the height of the tree. Well, I know these are similar. So I have the height of the tree over the height of the person equals the length of the shadow over the length of the shadow. Cross multiply. 1.5x equals 65. Divide by 1.5. And I get the tree is 43.333 feet tall. Next one, a flagpole. The flagpole casts a 20-meter shadow, while a 1.5-meter person casts a shadow that's 1.2 meters long. I want to find the height of the flagpole. Set my proportion. The height of the flagpole over the height of the person equals the flagpole shadow over the person's shadow. We cross multiply. 1.2x equals 30. Divide by 1.2. I get x equals 25 meters. So the shadow, or the tree is, or the flagpole is 25 meters long, tall. 26. A person places a mirror between herself and a building. Here's my mirror. Here's my building. Here's the person. The person is 3 meters away from the mirror. The mirror is 17.5 meters from both. All right, if she is 2 meters tall, how tall is the building? Okay, height of the person over the height of the building. Distance from the mirror over distance from mirror to building. Cross multiply. 17.5 times 2. 35 equals 3m. Divide by 3. X is 11.666 meters tall. $17. I want to find x and y. Well, let's find x. I know I want to use, so there's one triangle. And here's my other triangle. So I have a couple different things I can do. One potential thing I can do to find x is I can say, okay, well, length of, he uses the x in the little triangle is x. The length of the big piece is 2x plus 3, because I add them together. Then over here, I'd get 2x and then 3x plus 4. I also could do x over x plus 3 equals 2x over x plus 4. To find the y, you're going to need to use x's in the y's, but I know I need to use the 2y and the 3y plus 6. And then I can either use x over 2x plus 3 or 2x over 3x plus 4. Any one of those will work. 18, I need to set up some pieces. I know that 16 over 32 is proportional to y over y plus 3. Cross multiply. 16 times y plus 3 equals 32y. Distribute. 16y plus 48 equals 32y. Subtract the 16y. 48 equals 16y, divide by 16, I get y equals 3. All right, so with 19, I have two options again. I know that this piece here will be x minus 6 if the whole thing is x, and this piece is 6, and this is x minus 6, so I could do x minus 6 over 6 equals 3 over 8. Or easier, I could do x over 6 equals 11 over 8. Cross multiply, I get 8x equals 66. Divide by x, by 8, I get 8, x equals 8.25. All right, so with this one, I know that 15 over 8 equals x over 10. Cross multiply. 150 equals 8x. So I divide by 8. I get x equals 18.75. 21. Proofs. All right, so I know reason 1 is always given. Statement 2. I know that angle C is congruent to angle E because it tells me that ACE is an isosceles triangle with a vertex at A. So this is my base angles of isosceles triangles. Are congruent. Now, the next thing says me that CB over EF is equal to CD over ED. Well, that's right here. So this is also given. So I have a pair of angles and two pairs of sides that are proportional to each other. So I have side, angle, side, similarity. All right, I am trying to prove that CAE is similar to ABE. I'll draw these out separately. So I have so far, I'm given that CAE is equal to ABC. I also know it says that AEC is congruent to BEA. Well, it's the exact same angle. So this is reflexive property. So these two are similar by angle-angle similarity. 23. All right, so this is one of my coordinate plane ones. I need to find each of these pieces. The slope of ED, I have to go down 3 and then over 1. BF, I have to go down 6 over 2, which simplifies to negative 3 over 1. For AF, I have to go up 6 over 18, which simplifies to 1/3. For CE, I have to go up 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 3 over 9, which simplifies to 1/3. So I have some parallel lines in there, and I also have some perpendiculars. Let's look at what we have. Since ED and BF have the same slope, I know that ED is parallel to FB. Since AF and CE have the same slopes, I know AF is parallel to CE. If I look here, I know that BF and AF have opposite reciprocal slopes, so I know that there's a right angle. And I also know that ED and CE have opposite reciprocal slopes, so angle CED is also a right angle. So automatically, when I'm looking down here, I can say that angle F is congruent to angle E, which I can also write out as angle CED is congruent to angle FB because I have perpendicular lines. Two pairs of perpendicular lines. So I have right angles. Then if I look at my parallel lines, if I look over here, bring this up a little bit. I have parallel line, cut by a transversal, so I know that angle FAD is congruent to angle ECD because they're corresponding angles. I also could call this angle A is congruent to angle C. Again, using the parallel lines, I also know that FB is congruent to ED, so I have some more corresponding angles. I also could have used that angle CDE or angle D is congruent to angle ABF or angle B. And again, those are corresponding angles. I don't need all three, I just need two. So you could have chosen any two of those three pairs of angles. I need two pairs. So then I know that these two triangles are similar by angle-angle similarity. Next one's the same type of problem. I have to fill out all these, I have to find a bunch of slopes. FB, I had to go up 5 over 5, which simplifies to 1 over 1. ED, I had to go up 2 over 2, which simplifies to 1 over 1. AF, I had to go down 5 and over 5. So that's negative 1 over 1. And then CE, down 2 over 2, negative 2 over 2, which is negative 1 over 1. So again, I have some parallel lines. So again, this time I know that AF is parallel to CE. And so if I look here, I know that angle A is congruent to angle C because they're corresponding. I also can use corresponding because I know that AF and CE, or I know that FB and DE are congruent or parallel. So for the same reason, could also say that angle D is congruent to angle B because they're corresponding. Say you only notice one of those, you also still have some parallels in there. 1 and negative 1 are opposite reciprocals of each other. So I know that angle F and angle E are right angles. So again, if I could have also used that angle F is congruent to angle E because they're right angles. And again, I do not need all three pairs of sides. I only need two. And this is, again, similar by angle-angle similarity. Last page. I want to plot point S to that triangle hat, which is this triangle right here. It is similar to triangle SMT. Well, I need to find point S. Here's, I know it'll be over here because it has to be the same slopes. So I have two options here. First thing I'm going to do is I can look at, I know I have parallel lines because I cut a triangle in pieces. So I know the AH has a slope of up 1 over 3. AH is the slope of 1/3. So I know MS is also going to have a slope of 1/3. So I'm going to keep doing my 1/3 slope from M until I land on my line. So up 1/3. Not there yet. Up 1/3. Not there yet. Up 1/3. Ding, ding, ding. I am there. There's point S, so I can erase the rest of my line. So there's the rest of my triangle. I also could have used the fact that my sides have to have the same proportions. So I know if I did so I had to go over 1, down 2, and I had to do that 2 more times to get to point M. So I can figure out how I get from T to H. So I had to go down 1/2, and I have to do that 2 more times to get to point S. So there's point S. All right, 26, last problem. 26, I plot point S so that triangle, HAT. So be careful, because this time, even though M and H are horizontal, are the same line, I don't want to match up H and M. I want to match up HAT. So I want to make my triangle SMT. I know that S has to be somewhere on that line. And again, I'm going to show you both ways. So figure out my slope for AH. My slope is up 2 over 2 over 8, which is 1/4. So I'm going to go from M and do a slope of 1/4 until I get to my purple line. Up 1/4. Not there yet. Up 1/4. Not there yet. Up 1/4. I'm there. So there's point S. Again, also I can do my slope. I know that my slope from T to A was up 4/2, which simplifies to 2/1. From T to M, I had to go 2/1, 1, 2, 3 times. So I'm going to figure out my slope for this one. So TH 6/6. So that's to 1/1. I'll do 1/1 until I want to do it. I want to do this. In this one, doing your parallel line. So the purple way is the easier way to do it. Because my slope is 1/1, I can't just do it 3 times to get to point S. I have to do it. I'd have to use my slope as, I'd have to figure out because this would have to be 2. Jump through the slope, so I want to use 3/3. So I go over 3, up 3. Okay, not there. Over 3, up 3. I got to point H. Do it one more time. Over 3, up 3. There's point S. So there's my triangle. And there's your video. Come in, ask teacher any questions, and good luck studying and good luck on your test.